Hi guys, today we have a statistics question and we're gonna try to unpack it. So the question reads, Manon has two bias spinners, one red and one green. The random variable R represents the score when the red spinner is spun. The random variable G represents the score when the green spinner is spun. The probability distributions for R and G are given below. Okay, so what do I know? I know that, so first I need to read this, right, properly. So the probability R equals to lowercase r, right? So let's understand what this means. So the way I want you guys to do this is I want you guys to read this but replace R with its actual meaning. So we can see that capital R represents the score when the red spinner is spun. So now I want you to read this as the probability, the score when the red spinner is spun equals, now lowercase r. This lowercase r are my achievable values. So I could get a 2 or I could get a 3 in this case. So I want you to read this as the probability, the score when the red spinner is spun equals 2, for instance. So let's write that one out. The probability that capital R equals to 2 equals 1 over 4. All that's saying is the probability, the score when the red spinner is spun equals 2 equals a quarter. Okay? So that's pretty simple. Now that we understand that, let's try to unpack the question further. So we have the distribution for the red spinner and the green spinner, so that's great. It says Manon spins each spinner once and adds the two scores. Find the probability that the sum of the two scores is 7. So that's part I, and then for part II it says the sum of the two scores is less than 4. Okay? So what I'm going to do is I'm going to let A equal the score on my red spinner, and I'm going to let B equal the score on my green spinner. So that's great. Now I'm going to rewrite this, right? So I'm going to create my own notation, A comma B. I'm going to say that equals to A plus B. Now the reason I'm doing this is just to see what would happen, like what possible outcomes could I have when I add them together. So so I'm just going to do this systematically. So what I'm trying to do is I'm going to fix my red spinners 2 and just go through the possible values of my green spinners, right? So I'm going to say 2 comma 1, right? That's the first one I could get. That equals to 3. Then I'm going to say 2 comma 4. That would equal to 6. Then I'm going to say 3, right? Because I've done all the possibilities where my red spinner was a 2. Now I'm going to do all the possibilities where my red spinner is a 3. So I'm going to get 3 comma 1, and that equals to 4. Then I'm going to get 3 comma 4, which equals to 7. Great. Now I'm going to return to the question. So the question says the sum of the two scores is 7. Well, I can clearly see, so let me just do AI here. I can clearly see that there's only one case where the sum of the scores being 7, so it's not this one, it's not this one, it's not this one, but it is this one, right? So what does that tell me? It tells me that I need probability red to equal 3 and probability green to equal 4. Because I'm essentially trying to get red as 3 and green as 4 for them to sum to 7. Now what do I know? I know the probability red being a 3 is 3/4, and the probability that green is 4 is 1/3. So this just equals to 3/4 multiplied by 1/3, which simply becomes 1 over 4. So that's great. Now I'm going to do the next part. So that's AII. So let's try that. What does this part read? It says the sum of the two scores is less than 4. Okay? So when it says the sum of the two scores is less than 4, essentially that means that it has to be strictly less than 4. So we're saying A plus B has to be strictly less than 4. Okay? So let's return to the question and see when that is the case. So this would be fine because 3 is less than 4. This wouldn't work because 6 is greater than 4. Now, for this one, it's interesting. We have 4 equals to 4, but we require it to be strictly less than 4. So this one also wouldn't work. And then the last one wouldn't work either, because 7 is more than 4. So it's clear to see that this only works when red is 2 and we have green as 1. So I'm going to say probability red equaling 1, right? Sorry, that's meant to be a 2. And the probability that green equals to 1. What do I get from that? Well, the probability that red is 2 is a quarter, and the probability that green is 1 is 2/3. So let me just input that. 1/4 multiplied by 2/3, which simply becomes 1/6. Great, okay, I've gotten that now. Now let's try and do part B, okay? So if I'm doing part B, let's see what it says. It says the random variable x equals m capital R plus n capital G, where m and n are integers. We also know that the probability x equals to 20 is 1 out of 6, and the probability x equals to 50 is a quarter. Find the value of m and the value of n, okay? So first let's try to understand what this means. So when I have something of this form, which is x equals m capital R plus n capital G, m and n, so these two, right, they are just weightings. All they are weightings. And then I have capital R and capital G. Well, we know that these are the values on my spinner when I spin it, right? So let's write out what we have clearly. So we have probability x equals to 20 equals 1 out of 6, right? And we have probability x equals to 50 equals 1/4, right? So let's just return to double check that. That's great, that's fine. Our goal is to work out what m and n are, right? Well, I want you to see it like this. We know that for me to have probability x equals to 20 equals 1 out of 6, this 1 out of 6 is awfully familiar. If I return to the previous part, right, I saw that the only time that I would have a probability equaling to 1 out of 6 is when red equals to 2 and green equals to 1. So I'm going to write red equals to 2 and green equals to 1. Also, what do I know? I know that this a quarter is also very familiar, right? So when would I have a quarter? That's when probability red equals to 3 and probability green equals to 4. That's red equals to 3 and that's green equals to 4. Okay? So all I have to do is I can substitute red and green into my equation above, right? So let's just call this equation 1. I could sub it into equation 1. So I have 20 equals to 2m, because I'm replacing r with 2, plus 1n, because I'm replacing g with 1. And then I also would have the equation 50 equals to 3m plus, and then this would be 4n. Again, because I'm replacing g with 4. So this looks like simultaneous equations. And we know how to solve simultaneous equations, so let's do that. I'm going to multiply equation 1 by 4. So I'm just going to write equation 1 multiplied by 4. What do I receive? I get 80 equals 8m plus 4n. And below that I have 50 equals 3m plus 4n, right? Now I'm simply going to subtract my two equations. So let me do that here. I get 30 equals to 8m take away 3m is 5m, and then the 4n's cancel. So all I'm left with is 5m equals to 30, so it's clear to see that m must equal to 6. Now that I have m as 6, I'm going to sub it back in and solve for n, so I'm going to sub that back into equation 1. So sub m equals 6 into equation 1. What do I have now? I have 20 equals 2m add n, then I get 20 equals 2 multiplied by 6 plus n. Now it's clear to see that n equals to 12. So I'm just going to make my solution, not 12, n would be 8. So I have n equals to 8. So it's clear to see that my solution would be, just over here I'm just going to box it up, so I'm going to say m equals to 6, and I'm going to say n equals to 8. Just quickly box this up just for clarity. Done. Okay? So, I mean, it's quite a word question, it can be a bit tricky, but having said that, I think the best thing to do is just to really take it piece by piece and try your best to digest it. Thank you.